Yeah? Okay. Do you want me to do one that has a hydrogen attached? We'll get to that when we do a hydrate. How about that? Okay. Let's talk about molecular compounds. So let's leave ionic compounds for a minute and let's go to molecular compounds. Molecular compounds are made of non-metals. The non-metals are on the right-hand side of your periodic table, and you are going to use Greek prefixes to indicate the number of each atom that you have. On your periodic table, you have a mini table in the middle at the bottom right of all of the Greek prefixes. It's mono down to deca. You could highlight that in a different color if you wanted to, but you'll notice that the number 1 has a star next to it. That's because you only use mono with 1 oxygen. So if you have CO, then guess what? You can use mono to indicate that you have 1 oxygen. Otherwise, you will never use mono. Okay? All right, so on the next page, let's go here to these practice problems. So here it says, write the formula of the following molecular compounds. Let's change this to a better color. Nitrogen monoxide. This would just be NO. And the mono is here because it's 1 oxygen. Okay? Nitrogen dioxide would be NO2. Okay? C, dinitrogens. This is N2 tetroxides. That would be O4. Notice this doesn't say tetraoxide. Tetraoxide would be deemed the wrong way to write that. Okay? Dinitrogen trioxide, N2O3. Okay? If you're looking at 2, this would be phosphorus pentachloride. You change the ending of the second nonmetal to "ide." B, sulfur dioxide. C, carbon monoxide. We did that earlier. D, diphosphorus pentoxide or pentaoxide?
Pentoxide.
Pentoxide. Okay? Okay. Any questions on those? Yes.
For dinitrogen tetraoxide, do you need to simplify?
No, because then it would be NO2.
And
Totally different.
Totally
Name would be totally different.
Okay,
But
so
good question.
compound, covalent, you don't simplify?
Covalent, molecular, you don't simplify. Yeah. Yeah.
So the only time you take out the A in penta and tetra is with oxygen?
Right. That's a good question. I don't know if that's always true. I try to point the goofy ones out. Okay? Yeah. All right. Let's talk about hydrates. Okay? Hydrates are ionic compounds with water attached. Okay, so these are just, whoa, sorry, I thought I hit that. These are salts with water attached. Typically, if you want to get rid of the water, you just gently heat it with a Bunsen burner and the water will leave the crystal. Okay, when the water leaves the crystal, it's called anhydrous. That means without water. Some anhydrous salts are hygroscopic, which means they will absorb water from the air. So when you buy a new pair of shoes, you probably have a little container of salt, a little bag of salt in your shoebox. And that is something that's just going to absorb any water in the air to keep your shoes dry. This is called a desiccant. If you're working in a lab, we have a container that keeps salt in it that absorbs water, and that is called a desiccator. Okay, let's take a look at how to do these. Let's just jump straight into the practice problems right here. Okay. All right, so here I've got barium chloride dihydrate. So barium is Ba+2, chloride is Cl-1, so BaCl2 is the chemical formula for barium chloride. This dihydrate means I have 2 waters attached. We typically put that little dot, like a multiplication symbol there, and then you would put 2 H2O. after it. Okay. For sodium carbonate monohydrate, sodium is Na+1. Carbonate has oxygen attached to the carbon because it's ending in 8, so it's CO3-2. You would need 2 of those sodium ions to make it a neutral compound, so Na2CO3 is your formula. Monohydrate means you're going to have 1 water attached, and you don't have to put the number 1 in front of the water. Okay? If we are naming hydrates, so if we're doing 2A as an example, you'll notice that here I have cobalt and iron, which require us to calculate the charge on the metal because those are transition metals. I've got 2 chlorine. The charge on chlorine is a -1. You multiply the 2 and the -1 to get a -2. That means you need a +2 on the other side. So 1 cobalt at a +2 charge would give me that. So this is cobalt. Roman numeral 2 because of this charge. Chloride. I have 6 waters. So this would be hexahydrate. Okay. If you're doing C, we don't have to calculate the charge on sodium because it has an assigned charge. That's sodium. Cr2O7 is on the bottom left of your periodic table. That's dichromate. And then you've got 2 waters attached. So this is dihydrate. Okay. Let's talk about acids. Let's go down here. We have 2 different kinds of acids. Let me just write this here. You'll have binary acids and you'll have oxyacids. Okay? Binary acids contain hydrogen plus some other nonmetal dissolved in water. Okay, and there aren't very many of them. Binary acids, for naming them, you're going to have hydro in the front, ic at the end, and then acid. Okay, so if you have something like HCl, and you would have to put the AQ technically after it, otherwise it's called hydrogen chloride, which is something else. This would be hydrochloric acid. Okay, if you're going in the opposite direction, and let's say I gave you something called hydrosulfuric acid. Since it begins with hydro and ends with ic, it's a binary acid, and I gave you a little cheat sheet in the bottom of that periodic table. It says acids. Okay, so binary acids don't contain oxygen. Okay, so it says hydroic as a guide. So you would take hydrogen with its usual +1 charge. Sulfuric means you have sulfur attached. The charge for sulfur on your periodic table is a -2. You would need 2 hydrogens to balance out with sulfur's charge at a -2, so you'll get H2S. Put an AQ after it because that implies it's dissolved in water, and that's how you know it's a binary acid. Otherwise, it's called hydrogen sulfide. Okay? Oxyacids are hydrogen with a polyatomic ion containing oxygen. Okay, oxyacids, if you have the polyatomic ion containing oxygen ending in 8, it becomes ic acid. If the polyatomic ion containing oxygen ends in ite, it becomes OUS acid. Okay, that is also on the bottom right of your periodic table. Okay, so if you have something like HClO3 and you're trying to name it, you really need to identify the name of the polyatomic ion containing oxygen first. ClO3 is chlorate. Okay, so if it ends in 8, make it ic acid. So this name is actually chloric acid. Okay, if you have something like HNO2, again, you want to identify the name of that polyatomic ion containing oxygen. NO2 is nitrite, okay? Ites become OUS. So this becomes nitrous acid, okay? If you're going the opposite direction, you're looking at the ion charges, just like we were with these binary acids. So if I gave you something like sulfurous acid, okay? The OUS means I had ite to begin with. So you start with hydrogen, which is H plus 1. Sulfite would be SO3 negative 2. That means H2SO3 is the chemical formula for sulfurous acid. You do not have to put the AQ on the oxy acids. If you do, it's fine. It's not wrong. Okay? If I'm doing something like phosphoric acid, since this ends in ic, I have to have phosphate. So this would be hydrogen with phosphate, which is PO4 negative 3. The formula would be H3PO4. Do you want to do more practice? Or are you good? On the next page, I've got practice problems right here. Do you want me to do them? Yes. Okay. So if you take a look at number 1, hydrofluoric acid. Remember, hydroic means it's a binary acid. So that means it's only made of 2 things. It's made of hydrogen, and in this case, fluorine. So HF, and you have to put the AQ after binary acids. You have to show that it's dissolved in water. Okay. I have B, hypochlorous acid. Okay, so that means I have hydrogen. Hypochlorous means you have the hypochlorite ion. Hypochlorite is ClO negative 1. So HClO would be the chemical formula. Okay. For C, I have phosphoric acid. So that means I have phosphate attached to hydrogen. So hydrogen with phosphate would be H3PO4. Hydrosulfuric. The hydroic implies that this is another binary acid. So this is hydrogen with sulfur, and you get H2S, and you have to put the AQ after it because binary acids have to show the AQ so that they're dissolved in water. Okay, for number 2, make sure that you are naming the polyatomic ion containing oxygen first before you attempt to do anything else. Okay, so here, this is acetate. Ates become ic. So this is acetic acid. So this is how you name the oxy acids. Okay, for B, SO3 is sulfite. Ites become OUS. You would not name this sulfus because sulfurous sounds better. So this is SULFUROUS acid. Basically, you go with the one that sounds better. That's what people will tell you. Over here, CO3 is carbonate. Ates become ic. So this would be carbonic acid. Okay. Last one, D is the binary acid. Technically, it should have the AQ right here. Otherwise, it's really hydrogen iodide. So remember, binary acids begin with hydro, and then you put the non-metal and change the non-metal ending to ic. So this is hydroiodic